Okay guys, in this video I'm going to review for our exam, which is tomorrow. I'm going to go over the answers to our quiz questions. So question number 1 asks you to balance the following equations. And so the first one, I'm going to make my little reactants and products chart. So reactants and products. And then I'm going to write down how many of each reactant product I have. So in this first question I have PB, I have H, I have O, and I have Cl. And I broke up my O and my H here because I don't have an O and H together on the other side. So I decided I'm going to break them up. Okay. So I have, on this side I have 1 PB, on this side I have 1 PB. So that's even. Now I'm going to go and I'm going to look at my chlorines. Because remember, you always do hydrogen and oxygen last. So the next thing I'm going to look at are my chlorines. On this side I have 1 chlorine. But on the other side, I have 2 chlorines. So I need to somehow get 2 chlorines on this side, okay? So if I add a 2 here, that 2 gets distributed to this Cl. So now you have 2 chlorines on this side as well. Okay, so now you can either balance out your H's or O's, it doesn't matter. I usually balance H's first because I just like them better. Okay, so on this side I have 2 hydrogens because this 2 on the outside is multiplied by the elements on the inside. So I have 2 hydrogens here, but I also have 2 hydrogens here. So on this side, on my reactants, I have a total of 4 hydrogens. On the other side, I only have this 2 right here. So 2 hydrogens on the other side. So now I need to balance it out. If I have 4 here and 2 here, I need to get 2 more. So if I put a 2, it'll be 2 times 2, which is 4. So now I'm balanced on my PBs and my H's. Now I can look at my O's. On this side I have 2 times the oxygen, so that's 2 oxygens on this side. And on the other side I have 2 times this oxygen, so it's 2 O's. So I'm even. Okay, on the next problem it has me balance, so I'm going to do reactants and products. Zoom out here so you can see a little bit better. Our reactants, we have aluminum, bromine, potassium, and sulfate. Notice how I'm keeping the S and the O together here because I have the SO4 on one side and I have it on the other side. So it doesn't matter which one we do first. So I'm just going to start with aluminum. On the product side, I have 2 aluminums. On the reactant side, I have 1 aluminum. So I need to get another aluminum. So if I put a 2 here, that changes me to 2 aluminums. Okay, let's do bromines next. I have 2 times 3, so I have 6 bromines on this side, and I only have 1 on this other side, so I need 6 bromines right here. So I'm going to put a big 6. Give me 6 bromines. Okay, now let's look at potassium. Potassium here has a 2. Potassium on the other side, we have 6 potassiums. So how am I going to get this side to have 6? Well, if I put a 3 here, it'll be 3 times 2, which is 6, right? Okay, and lastly, I'll do my SO4s. On this side, it looks like I just have 1, but this 3 gets multiplied by that, so I actually have 3 SO4s. And then if you can look right here, you can see I also have 3 SO4s on this side. So my SO4s are balanced. Okay, now it's asking me to look at these different types of reactions here and describe or identify them. Well, let's look at the 2 that are already described for you. This one says one reactant breaks down into multiple products. That means we start with one thing, like right here, and we're breaking down into multiple things. So one reactant is a key, and breaking down is a key. This is going to be decomposition. Just something you have to memorize, and it's on your 9.2 notes if you need help with that. Synthesis is the opposite of this. So it's kind of like if I start with multiple reactants and I end up with 1 product. So I would put here multiple reactants forming 1 single product. So anytime you end up with 1 product, you're going to have synthesis because you're making something. This next one says we have a single element replacing another element in a compound as long as it is higher on the activity series. So here's your activity series right here. And elements that are at the top of it are more attractive, and elements that are at the bottom are less attractive. So the element at the top will always get the girl. The elements near the bottom will never get the girl. So here I write single replacement. These next two I have to describe what type of reactions occurring. In double replacement, it's similar to single except that it's two compounds, and in one of the compounds, the first element in each will swap places. Okay, so an example of that would be like if I had aluminum hydroxide, that's one compound, and let's say it's reacting with barium chloride. This is another second compound. The first elements will always switch. So Ba is going to be with OH, and then aluminum is going to be with chlorine. I just ran out of room, but anyway. So you see our first elements are swapping places, and then you can also tell it's double because you have a compound and a compound, and you end up with another compound and another compound. Last one's combustion. How can you tell if something's combustion? Well, you have some sort of reactant reacting with oxygen, and it's always going to form CO2 and water. That's how you know you have a combustion reaction. Anytime you have CO2 and water as a product, and anytime you have oxygen as a reactant, you have yourself a combustion reaction. Okay, now we're going to define these terms here. Precipitate just means a solid formed from a reaction. And then aqueous means anything dissolved in water. Okay, this next question asks us to identify the diatomics. I'll show you the diatomics on here first. Hydrogen is always a diatomic, always, always. And then the other diatomics, I call them the magic 7. So they start at element 7, which is nitrogen, and they're actually going to form a 7. So it's all of the elements right here. So it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine. So on here, which ones are diatomics? Aluminum's not, iodine is, iron's not, chlorine is, hydrogen is, potassium's not, calcium's not, carbon's not, nitrogen, fluorine, bromine, oxygen are all diatomics. Okay, this next question is asking us about, it's really asking us to do a math problem. It says, how much aluminum is needed? So aluminum is needed to react with zinc 2 sulfate. This is the charge of zinc, plus 2. Sulfate is SO4, and its charge is minus 2, so they're even. So you have aluminum reacting with zinc sulfate, and then you're going to form, it says to produce, what? What are you producing? It says aluminum sulfate, so I'm producing aluminum sulfate, and when I even out the charges, it'll look like that. And I'm also producing zinc. So the first step is always write out the actual equation. Write it out. So they gave you the word equation, write out the actual equation. Then you can add the math numbers under there. We have 19 grams of zinc. We don't know X. The arrow always stands for your equal sign. You're producing 206 grams of this guy and 25 grams of this guy. So I'm just solving for X here. So I'm going to add these two together, which gives me 231. And now to solve for X, all I have to do is subtract both sides by 19, which gives me 212. That's how many grams of, I guess, what was it, water? Aluminum was needed to react. Okay, this next question is asking us how to predict whether or not the reactions are going to occur. So I have here zinc and hydrochloric acid. Will this reaction happen? Well, the only way this reaction is going to happen is if zinc is higher on the activity series, it's going to pair with copper. It's going to steal hydrogen's girl. When we look on the list, zinc is higher than hydrogen. Here, I'll show you. Okay. Here is zinc, and here is hydrogen. Zinc is higher than hydrogen, so it's going to steal the girl. So this occurs. So I'll put a check mark. You could have put a check or a yes. Calcium and sodium chloride. So we have to look at calcium and sodium and see which one is higher on the chart. So here's calcium, and here's sodium. So calcium is more attractive than sodium, so this will also occur. Then you have zinc, and you have calcium sulfate. On the chart, calcium is higher up than zinc. Since calcium is higher, it's going to stay with its girl, so this is not going to react. Then you have calcium and hydrochloric acid. Hydrogen is low, and calcium is higher up. So calcium is going to get the girl, so this will react. And then we have copper, which is Cu, and hydrochloric acid. Copper is higher than hydrogen, so copper will steal the girl, so this will occur. And then you have potassium and barium nitrate. And barium is higher, or actually barium is lower than potassium, so potassium will steal the girl, so this will occur. And then this last one is silver and potassium chloride. Silver is low and potassium is higher, so potassium stays with his girl, so this is not going to occur. Question 7 asks us to find out what signs are a chemical reaction. Dissolving is a physical change, condensing is a physical change, and melting is a physical change. But all other parts here are chemical changes, so they're signs of a chemical reaction. Okay, we have one last question. On this question, it gives us atoms of gold. So I'm going to put that as my given over 1. Okay. And then I want to solve for grams. Well, I can't go atoms to grams. I have to always go through moles. So I need to put atoms on the bottom, and I'm going to moles. So what conversion factor has atoms and moles in it? Well, we learned that in 1 mole, there's always this many atoms. Now that I'm in moles, I cancel out of atoms. I need to go to grams. So moles has to be on the bottom, so cancel out, and grams is on the top. Since I'm going to grams of gold, I have to put the molar mass of gold here. Here's gold. It's Au, and its number is 196.967 in 1 mole. So all I have to do is multiply the numbers on the top and divide the numbers on the bottom. And I believe you get 0.006. Let me double check that real fast. Yes. That's actually 66. So that's how many grams. And that's it. That's it for our review. Good luck on your test. Study your notes. Study your skill check. And I will see you tomorrow.